a minimal Python library that lets you draw customized maps from OpenStreetMap. It uses the osmnx, matplotlib, shapely, and sketch packages to pull in map data, draw it, and export it as a vector graphic. The project is licensed under a GNU Affero General Public License version 3. That means you can use it for commercial projects, distribute it, and modify it, but you must disclose the source code and carry along the original license and copyright notice. When you use the library, always keep the printed credit on the resulting figures. The credit should include a reference to the repository and to OpenStreetMap because that is required by their license. The author is very against NFTs, stating concerns about their environmental impact, their use as a money laundering scheme, and the theft that the NFT community encourages. Therefore, this project is not authorized for selling NFTs, and those who have used the work for NFTs without crediting it have faced backlash from the community. The author also decided to stop publishing new generative art projects on GitHub to protect himself from that community. For those who want to support the author, a coffee button is available on a third-party site. The library has already appeared on Hacker News and has a subreddit called prettymaps where enthusiasts discuss and share their map visualizations. Tutorials are available in two forms, a Miro notebook and a Google Collaboratory demo. The notebook is a runnable Python file that walks through creating maps, customizing parameters, and using the various presets and advanced features such as hillshade and multiplet. To install the library locally, you type a single command into your terminal or command prompt, pip install prettymaps. On Google Collaboratory you install it by running a single line that requests the package from its GitHub repository and then restarting the runtime before you import it. Pip install egit plus https GitHub marceloprates prettymaps egg equals prettymaps. After restarting, you can import prettymaps in your notebook. If you want to run the built-in Streamlit frontend, you simply open the repository directory and run Streamlit run app.py. The full tutorial is included in the documentation as a markdown walkthrough. It covers the plot data class fields, the layers and style parameters, presets, multiplet, hillshade, and key points. The tutorial also shows how to use the library in a simple quick start snippet. First you import prettymaps, then you call prettymaps plot with the address of the location you want to visualize. For example, import prettymaps plot equals prettymaps plots to Van de Zon, here Hugoard, Netherlands. The tutorial teaches how to adapt the most important parameters. The plot function is a data class that contains the geometric data as separate geodata frames for each layer, the matplotlib figure, and the axis. The main arguments you can tweak are, layers, a dictionary of OpenStreetMap layers to retrieve. You can specify tags to control what features are drawn, style, a dictionary of matplotlib style options for each layer, such as face color or edge color, preset, a JSON file that contains a collection of presets for particular styles or layouts. Typical values are default, minimal, Macau, or Tijuca, circle, radius, delete. You can draw a round boundary around a location, set its radius in meters, and optionally enlarge the area. As an example, the library can be used to draw the Praça Ferreira do Amaral in Macau. You request water bodies that are natural in the tags water or bay, and buildings that are marked as building. You set the water face color to light blue and its edge color to dark tone, while you give buildings a palette of warm colors. The code would look something like, plot equals prettymaps plot Praça Ferreira do Amaral, Macau, circle equals true, radius equals 1100, layers equals, water, tags natural, water, bay, building, tags, building, true, style equals, water, FC, A1E3FF, EC, number 2F3737, building, palette, FFC 857, E9724C, C5283D. The tutorial also covers more advanced topics such as creating mosaics, visualizing a multiplet grid, adding hillshade, and using key points to annotate the map. All of this is documented in the Markdown guide, and you can see rendered images showing each preset and customization. For anyone interested, the full repository contains a tutorial notebook you can open locally, a Google Colab file you can run in the cloud, and a Streamlit frontend for quick interactive experimentation. The code is open source, well documented, and ready to use for anyone who wants to produce beautiful, custom maps from OpenStreetMap data.